are different. Zooplankton are your animals that are plankton. Okay, so these are animals. And zooplankton are also very, very important in the food chain because they act as a very critical step in the food chain. So phytoplankton are teeny tiny little microscopic things that you saw under the microscope. Not many things can go around and like eat phytoplankton because they're so small, right? You can't like go take a mouthful of water and like filter out the phytoplankton and eat them, okay? But the zooplankton, like copepods and stuff like that that you looked at, those are small enough to be able to eat the phytoplankton and then they're big enough to get eaten by other things. So they're the critical step that takes and makes all of that energy that's available in the phytoplankton step available to higher levels of the food chain by eating the phytoplankton and passing the energy up. Okay. They also act as a dispersal phase, and we'll talk more about that. But most types of benthic animals will have some sort of zooplankton stage where they will be part of the plankton for a little bit of their life. Okay. So we have two different kinds of plankton, zooplankton. You have holoplankton and muroplankton. Okay. Holoplankton and muroplankton. And I was taught how to remember this using kind of a silly way, but it helps me to remember it, and so I'm going to teach that to you, and if it helps you to remember it, then yay, okay? And I'm going to make a fool of myself and use a really bad accent. So, you're welcome, okay? So, holoplankton, they spend their whole life as plankton, okay? So, holoplankton, whole life as plankton. So they spend their entire life as plankton. So, yeah, that's not going to happen again. Nice try, though. So, here's some different kinds of holoplankton. Okay? You have different crustaceans. Krill and copepods are two of the most common types of holoplankton. Okay, so these are a couple different species of copepods. Here's krill. Okay, krill is what whales eat. Okay, so we've got lots of different kinds of holoplankton. Guys. And then you've got true jellies, which are also holoplankton. Okay, so spend their whole life as plankton. Different kinds of things that are holoplankton. These are ctenophores. Okay, we're going to talk about pretty much all of these animals in greater detail as we go through and talk about, like, do our survey of marine life, which we're going to start in, like, a cycle. So I'm just going to briefly talk about these, okay, and we'll talk about them in more detail later. But ctenophores, they're little gelatinous creatures, and they are really cool. You'll actually see these at the aquarium when we go. They're gelatinous, and they have cilia on their bodies in 8 rows. They're called teens, okay? And the cilia are fused together, and when they beat these cilia in order to be able to move, they act as a prism. So when light shines on them, it actually looks like they've got rainbows like running down their sides because they've got because of these cilia. So you'll see them at the aquarium. They look really cool. They're like this big, and they're awesome. So that's ctenophores, and they stick out these big feeding tentacles that capture food for them. The Portuguese man of war is also holoplankton. Siphonophores and salps, we're going to talk about both of those, but they are holoplankton. It's when they're like drifting around in the water. You've also got larvaceans, okay? I know these don't look like animals, but they actually are. It's weird, okay? But larvaceans. You've also got things like sea butterflies, okay? These are basically snails that don't have a shell, and they spend their whole life floating around in the water column. So they're pelagic gastropods. That's the sea butterfly. We'll talk more about that guy, too. Okay, muroplankton. Muroplankton only spend part of their life as plankton. Okay, so they're only plankton for part of their life. So, for example, about 75% of benthic invertebrates, as well as fish, have a muroplankton stage of life. So they start off life as a juvenile, as a larva, floating around in the plankton, And then eventually the benthic animals, they settle out and become benthic. They live on the bottom. Or like the fish start to be able to swim well enough that they can swim against the current and then are no longer considered to be plankton. Okay, so they do have a part of their life as plankton. It's their larval stage. Okay, this is also the dispersal phase for most of the benthic creatures. Basically, it's good for them to have this larval stage of life, plankton stage of life, because they're able to move away farther and faster than they could if they were like crawling away, right? So they get lifted up by the current and carried away and dispersed. That is a good thing. They go farther, faster. The microplankton stage of life may not look anything at all like the adult stage. So you can take like a sample of water and look at it and like see all of these things and have no idea that this is actually the juvenile stage for a barnacle, because they look completely different. So they can look strange. As their larval stage of life, their juvenile stage of life, they actually have to settle down and become adults somewhere. They have to pick their adult habitat if they're a benthic creature. And they have several ways that they will use to find out the right place to settle down. They can actually smell for other adults, and if they smell other adults of their species, that kind of tells them, like, oh, yeah, this is probably a good place to settle down because adults of my species can survive here. Or they'll feel for the right currents. So if the currents are right, then they'll settle down. Or they'll smell for their food source, and if they smell a lot of their food source, then they'll settle down. But it's kind of a big decision for them to make, because like barnacles, literally when they settle down, they cement their head to a rock, so they're not moving. And so they have to get it right, or else, you know, they don't survive, they die. It's kind of like being a senior in high school, right? You have to choose where you're going to go to college, what path you're going to take, what major. There's a lot of big decisions, right? It's like our neuroplankton. Okay, so here's a couple pictures for you. This is an abalone. That's the adult form. Okay, this is an abalone shell. They're like snails, but they have like one shell that's not curled like a snail does. So that's an abalone shell, adult abalone. And then here's their microplankton stage of life. So they have a little small stage. And then here's your brittle star. Okay, so here's the adult form of the brittle star, and then here's the microplankton stage. So that's what they look like as microplankton. Here's your juvenile barnacle, and then here's what a barnacle looks like when it settles down. Okay, and then here's your sunfish, your adult sunfish. Okay, and then here's your baby sunfish. Okay, the sunfish can get like 30 feet. So you can see you see the person right here? Yeah, that's a person. So yeah, it's a fin above and below, and they swim like using their fins like that. And that is the back of their body, right? So it looks like they kind of got cut off. So they don't really have like a normal tail like a normal fish does. They don't have like a caudal fin. They don't have a tail. It's just that's the end of it. Yeah, they look super weird. It looks like they got like bit off at the back, and like, but that's how they all are. They're not super fast, no. They don't. They eat deep sea jellies, so they spend most of their days down in the deep water eating jellyfish, and then they come up to the surface. And the reason why they got their name, the sunfish, is because they lay on the surface in the sun to warm up, and then they have birds that actually come and will land on the surface and pick out parasites from their body. So they're actually the heaviest fish in the ocean. Yeah. Our coast. Yeah.
Really?
Yeah. If you go to the Monterey Bay Aquarium, they actually a lot of times will have them in their like outer open ocean tank, and they'll be. I mean, they're not as big as like they normally get because they'll release them. Huh? No, it's too big to keep in Long Beach. So they're not that rare, no.
So like 30 feet is like the biggest you can get?
Yeah, they're gonna be that's gonna be like the biggest. Yeah, it's huge. That's not a small fish. And they grow that large just feeding on jellies, which is kind of crazy. As we talk about different animals, like different phylums of animals, we'll do what I call specimen spotlights. So we'll look at some really cool different animals that that are in the phylums that we talked about. So yeah, we'll talk about the sunfish some more because it's kind of awesome. Okay, so phytoplankton and zooplankton both need to stay up at the surface in the photic zone. They have a couple different reasons for needing to stay in the photic zone. The phytoplankton need to stay in the photic zone because they need to do photosynthesis, so they need sunlight. Zooplankton eat phytoplankton, so their food source is in the surface waters, so they need to stay up there in order to keep around their food source. Basically, phytoplankton and zooplankton are more dense than water and they sink. Okay, and they have all of these different adaptations and things that they'll use to reduce the rate at which they sink. Okay, and so what they'll do, they'll have a large surface area to volume ratio, meaning they'll be small but they'll be spread out. Okay, so you can think of it like, would you float better in your pool if you're all curled up into a ball, or if you like spread your arms and your legs out? Yeah, if you spread your arms and your legs out, right? So if you spread out, okay, you have more surface area, you sink more slowly. Okay, so they have a large surface area. This picture right here, okay, this one, that's the phytoplankton that has spines to help to increase its surface area. It also helps for protection because nothing wants to eat that because it'd be like eating a mouthful of needles, right? That would not feel good. So it helps to protect them as well. You also have diatoms that will convert the sugars that they make into oil rather than into like starches, because oil is less dense, right? So it'll help them to float. And then you've got your copepods and certain kinds of zooplankton that can swim. So they'll swim to try and stay at the surface. And then just one adaptation in general to avoid predation for plankton is they're see-through. So a lot of plankton are see-through, transparent. All right. So you'll see in your notes at the end, okay, that you have a bunch of different pictures, right? You see that? Okay. So be able to recognize those pictures and tell me whether they're holoplankton, myroplankton, phytoplankton, or zooplankton. Okay? So those are the pictures that I'll use, and you'll see